So if you were to, walk into a therapist's office anytime over the last century, or even just vent to a friend about feeling incredibly, overwhelmingly angry, you were almost guaranteed to hear the exact same advice.
Right. Let it out.
Exactly. You'd be told that if you don't let that anger out, it's going to build up inside you.
Right.
Like high-pressure steam in a pipe.
Yeah, the classic pressure cooker metaphor.
Right. And if you keep it bottled up long enough, eventually, inevitably, you're going to explode.
I mean, it is arguably one of the most pervasive psychological concepts in modern history, this whole idea that emotion is this physical substance that just accumulates and requires a literal physical release.
Yeah, we hear it literally everywhere. People are always saying things like, I just need to vent, or I'm about to blow a gasket. We have entire industries built around this, like those rage rooms.
Oh, yeah, where you pay to smash old TVs with a baseball bat.
Exactly.
Yeah.
But here's the thing. Modern neuroscience and evolutionary biology have recently come to this consensus that completely shatters that foundational idea. When you actually look at the brain, specifically, like a traumatized brain, there is no bottle.
None at all.
There's no pressurized fluid. There's no steam. So the question is, what is actually happening when a person snaps?
Welcome to Today in the Hypothesis. I'm so thrilled you're here with us for this conversation. Today, we are taking you on a mission to answer one of the behavioral science's oldest questions. Does trauma really bottle up rage until it explodes?
And, it's a question that goes way beyond just managing a bad temper. We're talking about the fundamental architecture of human survival here and how profound, inescapable adversity physically rewires that architecture.
Right. And to navigate this, we are diving into a truly massive paper by Victor H. Soutouche. It's called The Architecture of Traumatic Rage. Now, the synthesis was prepared by Gemini, and I really have to emphasize to you, the listener, right up front, this is not your standard psychology paper.
No, not even close.
Yeah.
Soutouche pulls off this wild, multidisciplinary tour de force. I mean, he's synthesizing evolutionary biology, deep brain neuroanatomy, molecular epigenetics, sociology, and even 19th century literature, all to build this unified theory of rage.
And what's fascinating here is how the synthesis completely dismantles our everyday metaphors for human emotion. We're going to look at how modern science takes that deeply comforting idea of bottling up a physical substance and reveals it to be a complete physiological myth.
Which is the central paradox we're unpacking today. Because the idea of a bottled-up explosion is actually incredibly accurate when you're just describing human behavior from the outside.
Right. Observationally, it makes perfect sense.
Yeah. Like, we've all seen someone suppress their feelings for years and then suddenly erupt because they, dropped a pen. It looks exactly like a pressure valve failing.
But the actual science of what's happening on the inside demands a total paradigm shift. So to figure out what happens when trauma distorts rage, I think we have to start at the very beginning.
Let's do it.
We have to understand why humans evolved to have anger in the first place. Because historically, if you look at early theorists like Thomas Hobbes or even William James, there was this prevailing assumption that humans just possessed these natural destructive instincts.
We were just inherently violent.
Exactly. They essentially viewed aggression as the savage drive, almost like a biological flaw that civilized society had to constantly actively suppress so we could all function.
The whole man in a state of nature is a beast concept.
Right. But modern evolutionary psychology looks at human behavior through a completely different lens. Every system in the human body consumes immense amounts of energy. Evolution doesn't preserve highly energetic systems just so we can randomly be savage,
It preserves systems that actually solve specific survival problems.
Yes. Which brings us to the recalibration theory of anger.
Okay, so this was proposed by researchers like Aaron Sell, John Tooby, and Lita Kosbines. And they argue that anger is not a loss of control. It's not a breakdown of the system at all.
Far from it. They propose that anger is actually a highly sophisticated computational system. It evolved specifically for status regulation and resource defense.
So it's not random violence.
No, it's a calculated deterrence strategy. Think about early hominids living in, small cooperative groups. If someone in your group tries to exploit you, maybe they steal your food or they physically threaten you, your brain needs a mechanism to stop that from happening again.
Because if you let them exploit you once, they'll just keep doing it.
Exactly. And your chances of survival plummet. So anger mobilizes your physiological system to impose retaliatory costs on that aggressor. The goal is to force them to, recalibrate how they value your welfare.
That is so interesting. You're basically communicating, hey, if you cross this line, the cost to you is going to be way too high.
Right, it deters future exploitation. It's basically a biological negotiation tactic.
I love that framing. It's a way of saying, you miscalculated my worth, so let me help you correct your math.
That's a great way to put it. And it's so sophisticated that it even features a built-in secondary system for forgiveness. Because in those small bands, once you impose that cost and stop the exploitation, you might still need that person to help you hunt the next day.
Right. You can't just kill everyone who slights you. You'd be totally alone.
Exactly. You need a way to restore the cooperative bond once the threat is neutralized.
Okay, let's unpack this for a second. Because this evolutionary blueprint makes a huge assumption. It assumes you actually have a level playing field. It assumes you have the power to negotiate.
And that is exactly where trauma disrupts the entire system.
Right. Because in cases of violent, inescapable trauma, we're talking about chronic childhood abuse, severe domestic violence, systemic oppression, the victim is entirely powerless.
They are. The evolutionary deterrence mechanism simply cannot be deployed.
You can't impose a physical or social cost on an abuser who has complete, unyielding control over your life.
That is the crux of the disruption. Your survival energy is massively mobilized. Your nervous system is screaming at you to fight back, to impose a cost to save yourself. But that action is violently thwarted by reality.
The energy is summoned, but the output is completely blocked.
Right. And to understand what happens to that thwarted energy, Sturchis's paper brings in the work of Jack Panksepp. He's a massive figure in effective neuroscience. He mapped out the exact emotional operating systems of the mammalian brain.
And he did this through decades of really rigorous research, right?
Yeah.
It wasn't just theorizing.
No, he used localized brain lesions and electrical stimulation in animal models to map exactly where emotions live. By stimulating very specific neural coordinates, he could reliably produce distinct behavioral states.
So these aren't just abstract ideas. These are literal physical circuits made of flesh and electricity.
Exactly. Panksepp identified 7 core effective systems, and he capitalized the names to show their specific neural networks. They are seeking, rage, fear, lust, care, panic or grief, and play.
And the most critical detail for you, the listener, trying to understand traumatic anger, is where the rage system is located.
Yeah.
Because it's subcortical.
Which means it sits way below the cerebral cortex. The cortex is that wrinkly outer layer where we do all our conscious thinking and rationalizing.
So the fact that it's subcortical changes everything. It means this circuitry originates in the deepest, most ancient structures of the brain.
It operates completely instinctually. It is incredibly rapid, and it functions entirely below the threshold of conscious thought. You don't sit down and rationally decide to activate your rage circuit.
It's an alarm system, not a debate club.
Perfectly said. When you're subjected to violent trauma, this primitive survival circuitry lights up instantly. But if the threat is insurmountable and you can't fight back, that rage circuit gets temporarily overridden by other survival systems, like dissociation or freezing.
But the critical point is that the rage circuit doesn't just power down, right?
No, it doesn't disappear. It enters this state of latent, continuous hypervigilance.
Which brings us right back to that massive myth we talked about at the top of the show, the hydraulic model. Now that we understand the neural basis of anger, we can see exactly why early psychology got this so incredibly wrong.
Yeah, the hydraulic model is really the legacy of late 19th century psychoanalysis. Sigmund Freud framed human behavior as this constant battle between opposing forces. Eros, the life instinct, and Thanatos, the death instinct or aggressive drive.
And it's no coincidence he formulated this during the Industrial Revolution. Humans always use the technology of their era to explain the brain.
Right. Today we say the brain is a computer. Freud said it was a steam pipe.
Exactly. And his daughter, Anna Freud, along with Konrad Lorenz, they formalized this into the hydraulic model. They literally described aggressive energy as something that builds up inside the psyche, like high-pressure steam inside a closed pipe.
In their view, severe trauma creates this constant input of aggressive energy, and if you keep it bottled up, the pressure continuously builds until the pipe inevitably ruptures.
Now, the explosion is viewed as a physical necessity. Yes. And this dictated therapy for decades. It gave us the whole mainstream concept of catharsis. The idea that you have to actively let off steam by shouting into a pillow or hitting a punching bag.
But Sturchis's paper is completely unequivocal on this point. Modern empirical science has disproved the hydraulic model entirely. There is no fluid,
No steam.
no pressure valve. So I want to offer you a different way to visualize this, something that actually aligns with the neuroscience.
I'd love to hear it.
Instead of a glass bottle filling up with water until it shatters, think of your brain's trauma response like a computer keyboard.
Okay.
But someone, a malicious hacker, has secretly reprogrammed a shortcut. You think you're just pressing Ctrl plus C to copy something mundane, like maybe someone bumps into you at the grocery store, or your boss sends a slightly blunt email.
Right. Totally normal stressors.
But the code was rewritten in the background during your trauma and you didn't know it. So when you hit that mundane shortcut, it triggers a massive system-wide override. The computer doesn't copy the text, it initiates a total system lockdown and starts flashing red. That is a much more accurate framework. It shifts us completely away from the idea of a physical substance building up.
Because the steam pipe model stuck around because it intuitively feels right, doesn't it? When you're angry, you literally feel physical pressure in your chest.
Your face gets hot, yeah. But neurologically, that isn't a substance trying to escape. It's a circuit firing. It's your ancient survival circuitry being held in this permanent, sensitized state of hypervigilance, just waiting for someone to accidentally hit Shiddle plus C.
Okay, but let me push back a little here to make sure we're really grounding this for everyone.
Right.
If the steam pipe model is completely wrong, why does it endure for so many years? Like, where exactly is this rewritten code physically stored in the brain? If it's just a circuit, why doesn't the circuit simply power down when the abuser finally leaves the room?
That is the exact right question to ask. And to answer it, we have to move into literal, hard neuroanatomy. We have to look at a structure in the midbrain called the periaqueductal gray, or the PEG.
The PEG. Sertuche calls it the brain's epicenter for defensive behaviors.
You can think of the PEG as the grand orchestrator of your deepest survival instincts. It's like a convergence zone. It takes in signals from the higher-up areas processing your environment, and it sends rapid commands down into the brainstem to control your autonomic nervous system.
So it's controlling heart rate, blood pressure, pain modulation.
Yes, even involuntary vocalizations during a threat. But what's truly remarkable is its internal organization. It's not just one big alarm bell. It's divided into columns that handle completely opposite types of defensive behavior.
Depending on the nature of the threat.
Right. The two primary divisions we need to focus on are the ventral PEG, the VPEG, and the dorsal PEG, the DPEG. Let's start with the VPEG.
The VPEG manages passive coping.
Exactly. It's heavily tied to the parasympathetic nervous system. When an organism perceives a threat as totally insurmountable, like a human trapped in severe, inescapable trauma, the VPEG takes over. Fighting back will get you killed. Running is impossible. So the VPEG initiates a profound state of hyperarousal.
Hyperarousal. A massive drop in system activity, basically shutting down.
Shutting down completely. Freezing, immobility, total submission. The VP even orchestrates the release of deep endogenous opioids to create severe analgesia. It literally numbs the body to physical pain in anticipation of injury.
And psychologically, this is the mechanism behind what trauma survivors describe as dissociation, isn't it?
Yes, exactly.
That terrifying feeling of floating above your own body or feeling like the world isn't real. It feels like a psychological break, but it's actually the VPEG executing a highly successful evolutionary survival script.
It's the brain doing exactly what it was designed to do to survive the unsurvivable. But then you look at the other side of the structure, the dorsal PEG. Its function is the polar opposite.
This is the primary output center for active coping.
Yes. The DPEG is the core engine of the fight-or-flight system. It's heavily sympathetic, driven by massive surges of adrenaline. When it's stimulated, it doesn't shut you down. It triggers extreme excitation, racing heart, elevated blood pressure, explosive escape behaviors, and if cornered, reactive, violent aggression.
This is the anatomical home of pure rage.
It is. So let's map this onto the timeline of severe trauma. During the actual event, say years of chronic childhood abuse, the immediate response might rely heavily on that VP freeze state. The child uses dissociation to survive, but the memory of the threat, the lasting physiological legacy, encodes heavily in the DPEG.
This is where the physical rewiring happens.
Right. The neural circuitry of the DPEG undergoes long-lasting maladaptive plastic changes. Neuroplasticity is usually how we learn, but here, the brain is learning danger way too well.
Because in a neurotypical brain, if you hear a loud bang, your DPEG flares up for a second, but then your prefrontal cortex analyzes it and says, relax, it's just a car backfiring.
The higher brain sends an inhibitory signal down, and the fear is deactivated. But Sertuche points out that neuroimaging of traumatized brains shows something incredibly alarming. Their DPEG exhibits significantly increased resting state activity.
It's stuck in a state of chronic hyperarousal. Even when they're sitting safely in a quiet room, the engine is just revving in the background.
Yes. And the DPAG doesn't act alone, it interacts extensively with the amygdala.
The famous threat detector. The radar system constantly scanning for anything that looks or sounds like the original trauma.
Right, it's a highly efficient alarm loop. But here is the ultimate tragedy of severe trauma. Structural MRIs consistently show that early abuse actually reduces the physical volume of the hippocampus in adulthood.
Let's explain the hippocampus clearly, because this is the linchpin. The hippocampus forms memories, but specifically, it provides context.
Context is everything. It's supposed to be the rational timekeeper. It tells the amygdala, look around, we are sitting in our living room in 2026. We are not trapped in 1998.
But because of that stress-induced hippocampal shrinkage, the toxic levels of chronic cortisol actually damage those neurons. The brain loses that contextualizing ability. It loses the ability to tell the difference between a safe environment now and a dangerous one in the past.
So consider the architecture of this trap. The context provider is damaged, the threat detector is stuck in overdrive, and the active defense circuitry is permanently sensitized.
Which brings us to the nature of triggers. We usually think of triggers as external, right? A certain smell, a tone of voice, a loud noise. But the paper highlights this concept that I found absolutely terrifying. Interoception.
Interoception is sensing your own internal physiological body signals, knowing you're hungry or that your muscles are tense.
And for traumatized individuals, triggers aren't just external. If they suddenly experience an elevated heart rate, and maybe they're just walking up the stairs, or they drank too much coffee, their hypervigilant amygdala senses that internal physical change.
And because it lacks the hippocampal context to know it's just coffee, the amygdala interprets that sensation as a conditioned stimulus for danger. The heartbeat itself becomes the trigger.
The body's normal fluctuations are misinterpreted as an incoming attack. That is incredibly intense.
It is. The trigger happens, the amygdala processes it as an imminent threat and routes the signal directly down to the hyperreactive DPAG. And crucially, this pathway completely bypasses higher-order cognitive processing. It bypasses the prefrontal cortex.
Okay, let's unpack this. Why on earth would the brain intentionally bypass its smartest, most rational component when it needs to solve a problem?
Because thinking takes time. In a true life or death scenario, the brain literally doesn't have the milliseconds required for you to consciously ponder your options. If a tiger jumps out, you don't analyze its trajectory, you just react. The subcortical shortcut sacrifices accuracy for speed.
So when a traumatized person has an explosive episode of rage, this isn't a conscious choice. They didn't decide to get angry. It's a subcortical shortcut completely overriding their conscious mind.
Exactly. On the outside, it looks exactly like the bottled-up steam explosion from the old hypothesis, but the mechanism is entirely neural. It's a hijacked circuit, not a hydraulic release.
Which forces us to completely rethink how we handle and treat anger. If the rage isn't a pressurized fluid that needs venting, how are we supposed to deal with it?
Well, this leads us to debunking one of the most stubborn pieces of pop psychology out there, the supposed danger of not venting.
Oh yes, we all know the standard advice. Go scream into a pillow, go hit a punching bag, let it out so it doesn't eat you alive.
But the paper cites over 50 years of empirical research that completely destroys the catharsis myth. Surtees points to foundational experiments by Hornberger and much more modern studies by Brad Bushman.
Bushman's studies are wild. Tell the listener how he set these up.
He would bring participants into a lab and deliberately infuriate them. He'd have them write an essay, and then an actor working for the experimenter would grade it and leave incredibly insulting, demeaning feedback. This is the worst essay I've ever read.
So the participants are furious, their DPAGs are firing.
Right. Then he divided them up. One group was told to hit a punching bag while ruminating on the person who insulted them. The hydraulic model would confidently predict that this group should feel much better afterward.
The physical exertion should open the valve and let the steam out.
Exactly. But the results were the exact opposite. Afterward, participants had a chance to administer loud, unpleasant blasts of noise to the person who insulted them. The ones who hit the punching bag were significantly more hostile and administered louder, longer noise blasts compared to the control groups who just sat quietly.
So the physical act of venting didn't release the anger. It literally poured gasoline on it. Venting is just steaming.
Because fundamentally, you aren't emptying a bottle, you're practicing the neural shortcut. By hitting the bag while thinking about the insult, you are actively reinforcing the exact cognitive attributions that made you angry.
You're training your nervous system.
You're making the pathways between the amygdala and the DPAG more efficient at triggering violent rage. The circuits you exercise are the circuits that grow stronger.
Right. So we have to replace the hydraulic model with Leonard Berkowitz's cognitive neo-association theory, or CNT.
Yes. CNT throws out the stored energy idea entirely. Berkowitz argues that aversive events, a traumatic memory, an insult, even physical pain, produce a baseline state of negative affect.
And this negative affect acts like a spark that lights up a dense associative network in the brain, a literal neural web.
And in our cognitive architecture, neurons that fire together wire together. A traumatic experience doesn't just record a video of what happened. It deeply links feelings of vulnerability, specific cues, interoceptive fear states, and aggressive motor tendencies. They're all woven together.
So when a trigger happens today, it doesn't uncap a bottle. It snags a thread on that web. And the cue travels instantly down that sensitized pathway, lighting up the entire network at once. You're hijacked by your own associative network.
Which is why the old hypothesis is behaviorally correct but mechanistically disastrous. The trauma built a web of hypervigilance. It didn't store a substance.
Wait, I have to step in here and challenge this a bit. I understand the punching bag study, but I struggle to believe venting is always universally bad. I know for a fact that I've felt profound relief after going for a really aggressive run when I'm mad. Are you saying the feeling of relief is just an illusion?
No, that's a crucial distinction. The relief isn't an illusion, but the source of the relief is misunderstood. When you go for a hard run, you aren't draining a reservoir of anger. You're doing two physiological things. First, you're physically exhausting the body, forcing the nervous system to eventually downregulate.
Okay, that makes sense.
Second, unless you spend the entire run obsessively ruminating on the person who made you mad, the run acts as a cognitive distraction.
You break the rumination cycle.
Exactly. The danger of venting lies in the association. If you act aggressively while focusing on the trigger, you strengthen the web. But intense physical activity that demands cognitive focus, like navigating a trail, allows the negative effect to dissipate without reinforcing the aggressive pathway.
Okay, that clears it up perfectly. But it still leaves us with this daunting reality. Recognizing that we have this sensitized web is the first step to rewiring it, right?
Right.
But what makes this so overwhelming is that the source material reveals this rewiring isn't just an individual burden.
This is perhaps the most paradigm-shifting section of the entire paper. This highly sensitized neural wiring can actually be passed down to people who never even experienced the original trauma.
We are talking about epigenetics. This is where the story shifts from your personal history to the history of your ancestors. The biological embedding of severe trauma goes all the way down to the molecular level.
Think of your DNA sequence as the actual hardware of a computer. That doesn't change over your lifetime. But epigenetics are the software. They're tiny chemical tags, methyl groups, that attach to the outside of the DNA. They turn certain genes on or off, like a volume knob.
And the research on how trauma affects these tags is just breathtaking. The paper highlights landmark studies by researchers like Rachel Yehuda and Elizabeth Binder, focusing on Holocaust survivors and their children.
Yes. Yehuda's team focused on the FKBP5 gene, which regulates the glucocorticoid receptor. Simply put, it dictates how effectively your body responds to stress hormones like cortisol.
And if this gene is highly methylated, it's strongly linked to PTSD and severe anxiety. So they looked at 32 Holocaust survivors, the F0 generation.
Unsurprisingly, these survivors showed significant epigenetic alterations. Increased methylation at a specific location bin 3 site 6. Their stress hormone system was fundamentally chemically sensitized to survive hell by keeping the alarm system primed.
But then they look at the F1 generation, the adult offspring. They never experienced the Holocaust, and researchers rigorously controlled for any severe adversity in their own lives.
And the findings sent shockwaves through the scientific community. They found corresponding epigenetic changes in the exact same location of the FKBP5 gene in the children. The trauma was transcribed into the child's genetic expression.
But here's the massive twist. The survivor parents had increased methylation, but the offspring displayed changes in the opposite direction. The F1 generation had significantly decreased methylation at that exact site.
Evolutionarily, that directional shift is profound. It's theorized to be an intentional adaptation, a biological warning transmitted from the parent directly into the child before they're even born.
The parent's epigenome is basically leaving a chemical note saying, The world you're entering is incredibly dangerous. I need to prime your biology for hypervigilance immediately.
It fundamentally redefines predisposition. For you, the listener, it implies your deep triggers or your unusually low threshold for fight or flight. It might not even belong to you. It might be a biological legacy. The baseline required to trigger that rage circuit was lowered before you took your first breath.
It's an inherited biological vulnerability.
Mm.
But we don't live in a vacuum, right? We're interacting with the modern world. How do our current living conditions interact with this sensitized ancestral wiring?
Well, that brings us to macro stressors and a crucial concept called allostatic load. The baseline state of your stress response system is heavily dictated by your daily environment.
Let's define allostatic load clearly. It's the cumulative physiological wear and tear on your body from chronic stress.
Right. Think of your stress response like first gear in a car. It gives you a massive burst of power to get out of danger, but you aren't supposed to drive on the highway in first gear.
The engine would overheat and break down.
Exactly. When your fight or flight system turns on and off constantly, it floods your body with cortisol. Over time, that toxicity physically damages the neural machinery.
And in our modern world, nothing taxes this system quite like systemic financial stress. Poverty, housing insecurity, these are relentless, chronic biological stressors taxing the HPA axis.
And here is where the trap closes. When that system is continuously taxed, it severely compromises the prefrontal cortex. The stress literally impairs your higher order cognitive function.
And that's the exact part of the brain you need to send inhibitory signals down to the DPAG. It's the brakes.
Exactly. The brakes are worn out. So if you have an individual with inherited epigenetic vulnerability and you subject them to systemic financial hardship, you are actively disabling their biological brakes while stepping on the gas. The threshold for a minor trigger to activate a massive rage response plummets.
The paper notes that sociologically, this presents as increased interpersonal conflict in economically depressed areas. It's not a moral failing. The systemic stress forces the physiological eruption.
This interaction is powerfully articulated in historical context, too. Sertouche brings in Frantz Fanon's 1961 book, The Wretched of the Earth.
Fanon analyzed the deep psychological trauma inflicted by colonialism, viewing it as a continuous trauma that violently suppresses autonomy.
And I want to be exceptionally clear for our listeners. We are discussing Fanon's sociological analysis purely as a clinical observation from the text. We are not endorsing violence or taking a political side.
Absolutely. We're strictly looking at the mechanics of his theory. Fanon observed that this systemic subjugation generates an immense reservoir of latent rage, but because the colonizer holds absolute power, that rage cannot safely be directed upward.
The deterrence mechanism is thwarted, so the rage must be repressed. But repressed rage sensitizes the midbrain. Fanon noted clinically that this first manifests as horizontal violence directed at peers within the colonized community. The trigger is pulled, but the target is displaced.
He also noted massive somatization, severe physical illnesses caused by chronic distress. But eventually, under unrelenting brutality, that repressed energy reaches critical mass. The allostatic load becomes too high, and it erupts into revolutionary violence.
Fanon saw this as a necessary psychological catharsis to restore agency. Now, contemporary psychology rejects violence as a healing tool, but Fanon's macroanalysis perfectly captures the reality of the hypothesis on a societal scale. Systemic trauma forces the rage circuit underground, and triggers inevitably detonate it.
So what does this mean for you listening today? It means modern chronic stress is actively disabling the part of your brain needed to keep trauma networks in check. It's like pouring fuel in a sparking web.
And yet, human society often demands the exact opposite. Cultural and spiritual systems actively force people to bury their anger, creating the very illusion of the bottle we've debunking.
This section of the paper is so compelling. Let's talk about the phenomenon of hwabyung in Korea.
Hwabyung translates to fire illness or anger syndrome. In traditional Korean culture, there's a concept called jung, which heavily prioritizes collective harmony and familial duty above individual expression.
So imagine someone in this culture experiencing inescapable oppression, severe hardship, or abusive in-laws. The mandate of jung strictly forbids outward expression of anger.
But we know the DPEG is still firing. The amygdala is screaming. The organism survives socially by suppressing the emotion, but this generates a deep state of unresolved anger known as ham.
And when han is suppressed for decades, the allostatic load becomes crushing. It bypasses the mind and erupts physically, becomes hwabyung.
The symptoms are terrifying. Sensations of being on fire, a physical mass pushing up in the chest, respiratory suffocation, and sudden explosive anger attacks. It's highly prevalent in older, less educated women who've absorbed systemic stress without an outlet.
It's tragic. Society demands they suppress anger to be good, but cognitive dissonance doesn't deactivate the physiological threat response.
And this isn't just in Korea. Sartuch draws a direct comparison to Western societies, where similar trauma often manifests as borderline personality disorder, or BPD, particularly in women.
Because Western expectations often forbid female outward aggression too. Women are conditioned to internalize it, directing the pain inward, leading to self-harm or severe depression.
The cultural context changes the presentation, but the biological mechanism is identical. And religious frameworks do this too, through spiritual bypassing.
On by John Wellwood in the 80s, right?
Yeah.
Using spiritual beliefs to sidestep unresolved emotional issues.
Yes, framing natural trauma responses like anger as spiritually dangerous, labeling anger a sin or a low vibration.
Toxic positivity. Everything happens for a reason. If you feel anxiety, it's a spiritual attack.
It's an appealing escape route because processing trauma is agonizing, but the cost is devastating numbness, depression, and severe dissociation.
And when triggered, they lack emotional regulation skills, leading to explosive anger that contradicts their peaceful facade. So, if we can't vent by hitting things and we can't suppress it, how do we safely interact with this biological reality?
That brings us to art and sound. Humanity has intuitively understood this for centuries. We turn to literature and music.
The paper looks at Mary Shelley's Frankenstein.
Right. Analyzed clinically, it's a masterclass in psychological trauma. The creature embodies the abject, the violent return of repressed trauma.
He starts with primal trauma, total abandonment by his creator. He seeks connection, but meets violent systemic rejection. This systemic trauma is the catalyst for his rage.
Exactly. It aligns with Charcot's mimetic suggestive theory, acting out trauma because it can't be processed cognitively. Victor's refusal to recognize the creature's humanity is the ongoing trigger.
And Toni Morrison's Beloved explores this on a historical scale. The concept of rememory, the involuntary recall of the horrors of slavery.
The collective silencing attempts to create a national amnesia, but the trauma refuses to stay bottled up. It physically manifests, forcing characters to confront what they buried.
But literature is narrative. Music gives us a direct physiological interface to regulate it.
This is where acoustic science is brilliant. Music bypasses higher cortical filtering and goes straight to the subcortical systems, the amygdala and the peg.
So listening to high-intensity music, heavy metal, hardcore punk, deep blues serves as a safe mechanism for engaging that rage circuitry.
And it's fundamentally different from a punching bag. Hitting a bag reinforces hostility, but aggressive music provides an exogenous trigger.
An external trigger. The double kick drums, the distorted guitars, they safely activate the physiological arousal. Your heart races, but without requiring a violent behavioral output.
The music literally hacks the nervous system. It lets the network process the emotion, while your prefrontal cortex says, I am perfectly safe, I'm just listening to a record.
It's brilliant biological self-medication. So to synthesize this whole journey, rage is not a fluid in a bottle. It is neurologically wired into the ancient midbrain, permanently sensitizing the dorsal pack.
It's genetically codified by our ancestors through epigenetics, exacerbated by modern allostatic load, and tragically silenced by culture.
The bottle is an illusion created by a society that doesn't want to deal with the pain. The explosion is the activation of a highly sensitized neural web desperately trying to protect the organism.
Which leaves us with this final thought. If our bodies hold the epigenetic chemical memory of historical traumas we never experienced, and our culture forces us to suppress our natural reactions to those ghosts, how much of what we consider our core personality or our flaws is actually just our nervous system trying to protect us from a history we don't even consciously remember?
Wow, that is an incredible paradigm-shifting thought to end on. Thank you so much for joining us for today in The Hypothesis. If you found this exploration of trauma, evolutionary biology, and neuroanatomy as fascinating as we did, please subscribe to the show and share this conversation with someone who loves having their perspective completely changed. We'll see you next time.